So how do we justify the as-if randomization assumption? Well, there are at least two ways to do that. The first is you use your qualitative understanding of the context. And what I mean is you try to figure out exactly why some units were treated and why some units weren't, and then after knowing how this treatment assignment process worked, you argue that it was basically random assignment. That however they were doing it in the administrative bureau or whoever was deciding how to assign treatments, they just were doing it haphazardly and not with respect to anything that might affect your outcomes. So they weren't putting all the high ability people in the treatment group and all the low ability people in the control group, for example, or something like that. Or all the men in the treatment group and all the women in the control group. They're just doing it randomly. A second thing you can do is do something called a balance check. Okay? What that is you compare the average values of all the variables you observe, such as gender, in the treatment group with the control group. Okay? So the idea is if you actually had true randomization, like we saw in real controlled randomized experiments, if you actually had real randomization, then the average values of variables are going to be constant across your treatment and your control group. So there's going to be roughly the same percentage of men in the control group as in the treatment group. There's going to be the same percentage of senior citizens in the control group as in the treatment group, et cetera, et cetera, et cetera. So you can just check. You see some variables like gender, and is that true? Is it balanced across your treatment and control group? Now, the difference between a true randomized experiment and an as-if randomized natural experiment is that a true randomized experiment guarantees that you have balance across these two groups in both the observed variables, the things you have in your data that you're looking at, and the unobserved variables, the things that you didn't observe but might still affect outcomes. An as-if randomization assumption, you don't really know whether that's true. You're basically assuming it, and then you're trying to check it by saying, well, if it is true, then I should have balance in the observed variables. And so I could check for balance, and if I see they're balanced, I'm okay. But that doesn't guarantee that there's not unbalance in the variables you don't observe. Okay, so it helps you see whether there might be a problem, but it doesn't really prove that as-if randomization is true.